Today I'll be explaining some system design concepts and in particular some agentic system design. So you have to refer to Gaurav Sen and his masterclass on system design and other things, which is where I learned it from. So first of all, I'm just going to explain a few concepts in detail. So first of all, you can consider vertical versus horizontal scaling. What is vertical scaling is that if you have one server or one system, you have to add compute resources to that particular server or system and make it bigger. So that is what vertical scaling is. Horizontal scaling means you have to add more instances of the same server in parallel, like server 1, server 2, server 3, server 4, with the same sort of compute possibility or different. So let's come to load balancers now. Now, what particularly is a load balancer? Why do we need something like a load balancer? When you consider API requests and API calling and the architecture of a particular networking based solution, you will see that there are requests coming in from users and our server system has to handle it. So one good thing about this is that it can be based on consistent hashing, which is what I learned from those videos, and it can also be sequential like round robin, but that will lead to problems. So in consistent hashing, you can see that there is a ring like this, and there is a distribution of server 1, server 2, server 3, server 4, and etc. And those distributions are managed by hashing functions. So if you have an incoming request, you need to know which server the request is going towards. So for this, you hash the request and figure out, for example, based on the hashing criterion that it is going to server 1. At the same time, you hash the server for a position in the ring. Now, if your hashing operation and other such things are only based on the modular operator, the problem is that when you remove a server, the redistribution is such that there is a huge load on other servers, like maybe 60% goes off to one server. If one server dies, S2 dies for example, it goes to server 1. So how do we solve this issue? We solve this issue using something called virtual nodes. So basically we take a server and create multiple virtual nodes of that server on the same ring, such that any incoming request is redistributed properly. And the time complexity is O raised to k by n, and I will explain why it is in a while. What basically is time complexity? Time complexity is a mathematical concept for computer science, where you have something called the big O notation. Based on the big O notation, you calculate the time taken by a program to execute in mathematical terms, such as polynomial terms and non-polynomial terms and all of that. So consider, coming back to why it is O raised to k by n, O of k by n, you consider k to be the total number of keys in the system, which is request. Each key is a request per user, and n is the total number of servers. So this pertains to virtual nodes. The key insight is that if virtual nodes are distributed uniformly, each server has 1 by nth of the distribution. So multiplying that with the number of keys, you get k raised to n, which is why roughly it translates to O of k by n. So now we come to another concept such as gateways, monoliths versus microservice, and SQL versus nosql. I will explain this in brief. Gateways are something that is between your server and the API request coming in from the user. So gateways help in authentication, such as you have to authenticate whether the user is actually coming from your particular service or not, whether he pertains to as a user base particular person. So gateways help in authentication, and also one more thing is to mask internal architecture. Say you have a /home screen route, and the gateway will call 4 parallel requests from the /home screen route, and it will mask the internal callings of that particular API request. So when a microservice is useful, so suppose you have a WhatsApp group admin requirement, you have to basically only use a microservice versus a monolith, where monolith, the entire system architecture is defined as one, whereas in a microservice you can redistribute certain system architectural concepts to separate points. So when a microservice is useful, suppose you have a group microservice for WhatsApp, like that only pertains to group. I learned this from Gaurav Sen's videos. You can have something like set admin, get admin, which will set the administrator of a group, or get all admins pertaining to a group and other such things. So now let's go on to agentic system design. So where can we reuse these concepts? Basically all of these concepts can be reused in agentic system design, but pertaining to agentic AI and the large language model boom that's currently on the way, there's obviously a gateway and your user queries. Suppose it's support customer resource management based agentic system. So you have a gateway, and then your user query will route to a particular router agent. Why do we need a router agent? A router agent, if you know something like LangGraph, you will be familiar with something like a router agent. So a router agent will understand the context and classify intent. So after this, you need something to keep the user busy while your router agent thinks and all the internal processes are going on. So you will also use something like a Q&A agent to keep the user busy, telling him what's actually going on in a very high level view. Then you will have a planner agent. The planner agent plans out the execution of the steps that are required to fulfill the particular use case. Suppose it is, like I said, a customer support use case wherein a customer wants to return a particular item. Then the customer will first say, I want to return item X. Router agent classifies the intent. Q&A agent keeps the user busy. But the planner agent executes the steps. Now the planner agent will call APIs via tool calling. This is a very common thing in agentic AI, tool calling. Basically, it's a procedural steps that the agent will execute based on data. Now, another keyword you should remember is MCP. Model Context Protocol was introduced by Anthropic. So Model Context Protocol is better than traditional API hooks which you write to call APIs or external databases, because Model Context Protocol architecture basically has a client and a server, whereas wherein your Model Context Protocol server which you write will be pertain to a particular use case, and your client can bind to the Model Context Protocol server and call tools, MCP tools, which will be pertaining to a particular API service also. So other thing is retrieval augmented generation, which I have already explained. Suppose you want the policies of your particular return item to be negotiated with the user. You will basically create a vector database and set up RAG for this particular pipeline. Now coming to something like Ragas, which is another important thing. There are many other frameworks, but Ragas is one important framework, which means retrieval augmented generation assessment. So how faithful is your response? How precise is the context returned, and other such things will be taught by, given by the Ragas. Another important thing is observability and guardrails. So you're dealing with a large language model that is prone to prompt injection and other such things. So you have to set up a guardrails agent wherein you will be monitoring for certain parameters by which you can flag user query based on hate, based on violent tendencies in the user query, and you can customize the guardrails as well. And observability you can infuse in your agentic application by using some open source uh, open source frameworks such as LangFuse, which involves wrapping your code around a lot of LangFuse blocks, or you can use Langsmith and other such things. Okay, thank you.